Hello everyone. Today we're starting a new unit. With this one we're going to be talking about relations and functions. And before we get started talking about those, we're going to spend some time on some of the dictionary or the vocabulary that you need to learn. So, take notes along with me whenever you're finished. Go ahead and take a picture of the completed notes to Google Classroom. And let's go ahead and get started. So, the first one is the coordinate plane. And the definition is going to be formed by the intersection of two number lines and that's the horizontal axis and the vertical axis. Okay, and the picture of that would be this right here, and these cross each other at a 90-degree angle. So we're going to be messing with those a little bit more. Okay. Now, the x-axis. So the x-axis is the horizontal axis in the coordinate plane. So if we take our coordinate plane, this right here is the x-axis. Okay. The y-axis is the vertical axis on the coordinate plane. So if we have our coordinate plane once again, we have that this axis is going to be the y-axis. The quadrants, they are the four regions into which so they're the four regions into which the x and y axis separate the coordinate plane. So if we have our coordinate plane, we count these in a weird way, kind of. So up here is quadrant 1. Here is quadrant 2, quadrant 3, and quadrant 4. And we use Roman numerals to show this. Okay. Next definition is origin. The origin is the point at which the x and y-axis intersect on the coordinate plane. So, if we have our coordinate plane, just imagine that that's a 90-degree angle. Right here is the origin, and it is 0, 0. Okay. Next is, what is an ordered pair? So an ordered pair is a set of numbers or coordinates written in the form parentheses x comma y parentheses. So for example, if we have negative 1 comma 5, this relates to the x coordinate. This is the y coordinate. Okay? So the x coordinate is the x value of an ordered pair. And this represents the placement on the horizontal axis. So on the x-axis. Okay. Next page. The y-coordinate is very similar. So the y value of an ordered pair and this represents the vertical placement. On the y-axis. Okay. Now we have another term. It's a discrete graph. A discrete graph is a graph that consists of points that do not connect. So that are not connected, and that is a discrete graph. A continuous graph would be a function graphed with a line or smooth curve. So a function graphed with a line or smooth curve. Okay? So, let's move on to some more. This is relation. So relation, that just means a set of ordered pairs. So for example, we could have the set negative 1 comma 4, 0 comma 6, 5 comma negative 2, and that would be a set of ordered pairs. Okay? The domain is the set of first numbers, or in other words, the x values of the ordered pairs in a relation. Of the ordered pairs in the relation. So if we take the relation that I used above, the domain, so D would be equal to negative 1, comma, 0, comma, 5. So I'm taking the x values of each of the ordered pairs. Okay. The range is the set of second numbers, or in other words, the y values of the ordered pairs in the relation. So, if I use the same set as I did in the relation, our range would be 4, comma 6, comma negative 2. So I'm taking the y value out of each ordered pair. Now, when it comes to mapping, it's an illustration, so it illustrates how each element of the set, of the domain, is paired with the elements of the range. So if I have two circles, this is the domain, this is the range. If you remember, the domain was -1, 0, and 5. The range was 4, 6, and -2. Mapping would be -1 goes with 4, 0 goes with 6, 5 goes with -2. Okay? So it's basically, this is the x value, this is the y value. And once you have both of these things, it creates the ordered pair. So what does it mean to be a function? So a function is a relation in which each element of the domain is paired with exactly one element of the range. So, if you look up at our mapping, since each domain element is paired up with exactly one relation, this would be a function. Okay? Next, we're going to be talking about the next page, which starts out with function notation. So function notation is a way to name a function that is defined by an equation basically you replace y with f of x. So if we have the function y equals 3x minus 8, we can change that into function notation as f of x is equal to 3x minus 8, and that's it. The input is a value substituted for an x value in a function. So in other words, if we have f of 4 is equal to 3 times 4 minus 8, this guy right here is going to be the input. Okay. The output is the result of substituting a value into a function. So the result of substituting a value into a function. So we have, if we use the same example, we have f of 4 is equal to 3 times 4 minus 8. 3 times 4 is 12, minus 8 is 4. So this guy right here is the output of the function. Okay. Vertical line test. So the vertical line test says that if any vertical line passes through. The graph of a relation no more than once then that relation is a function. Okay? So, for example, a function would be like this. Since we have an imaginary vertical line going through the sky, it only touches the graph once. Therefore, this would be a function. So this is a function. But if we have instead something like this, if we make a vertical line, it touches twice. So this is not a function. So that's what we can use with the vertical line test. Next definition would be zeros. The zeros are the x-intercepts of the graph of a function the points of which f of x is equal to 0. So in other words, if we have a function that looks like this, we have a 0 here, here, and here. Basically, it's where it crosses the x-axis, and these are called zeros. Okay? Next, for arithmetic series, or sequences, an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate. So in other words, we can have 1, 4, 7, 10, so on. Okay? The common difference is the difference between each consecutive term. In the sequence. So in other words, if we have 1, 4, 7, 10, and so on, if we take the difference of any two terms, so let's say 4 and 1, the difference would be 3. So in other words, if we go from 1 to 4, we add 3. If we go to 4 to 7, we add 3. If we go to 7 to 10, we add 3. So each time, the difference is 3. Okay? And the arithmetic series formula is a formula used to find the nth term in an arithmetic sequence. And that formula is a sub n is equal to a sub 1 plus d times n minus 1. Okay? And that's going to be it for the notes. Keep these in your binder. This is going to be useful for you in the future. Basically, what you're going to be doing is checking periodically. Basically, if you have a question and you don't want to message me, you can look back on this page and it should have the answer somewhere. So if you have any questions about it, please let me know. Don't be intimidated by anything like this. We're going to go through all of these things separately. So just make sure that you're not panicking just because you don't know something on it yet. All of this stuff is future information. So again, in order to get credit for the video, please take a picture of the completed dictionary and upload it to Google Classroom. I hope you have a wonderful day.